All right, so this is the essential question that we're trying to answer. What I want to do in giving you the story of the atom is actually take you to the pattern of the electrons. That's where all the real interesting chemistry is. So hopefully I can get you there. If you have any trouble, make sure you hit me in the private chat. And one of the most interesting things that came out is that these elements or electrons that surround these nuclei have the ability to emit light. And so that's the story. That's going to be the end of the story. There's a rainbow at the end. All right, so let's go ahead and take a look at that. Notice how I set up my notes. I set up my notes to be processed later. I do my studies in layers. So the first time I do my pre-work, which usually comes off of the reading, and then I go to the lecture where the teacher helps me fill in the blanks. And then I do my post-processing where I start to add color and jazz and pictures and things that will help me remember. And so that's my process. I encourage you to do the same. So that's why I have a lot of space. That's why I use white paper. It's also better for video instead of doing line paper. But you can adjust as you see fit. Okay, so first I want to get into the story of the atom. We're going to do a little image on this side, and then I'm going to talk about these four white men that you guys are going to do research on. That'll be our day. Hopefully we can land this plane in time, and we'll just see how it goes. So first thing I want you to do over here, if you have some room or find a slot that works for you, is to write the word gold. Now I'm doing mine OLD. Ooh, let's make this money gold. All right, I'm gonna put mine here, and I'm going down probably to this second dot here. Okay, if you have to go across, that's fine, as long as you have enough space, or if you want to do it over here, whatever works for you. Okay, now what I'm also going to do is make this three-dimensional because I am a visual learner. Anybody who's in my Scholar Warrior class knows about that. And the other thing that I'm going to do is inspire you to consider adding color to your notes. I don't have time in our class to do too much of this, but I at least want to model that it is important to me, and I think it could also be beneficial to you. So this is what I would normally be doing in the post, kind of after the lecture on my own, or maybe that evening. I would go back over the notes, preferably the same day, and use that time to get the color in and really kind of stamp. I think that's what these modern kids call it, stamping the learning. All right, so this is my gold bar, okay? And what I'm going to do is start with our first white man. Maybe we could do 5. Let's add Aristotle in on this little white man journey too. So if you want Aristotle, hit me in the chat. I can probably approve that to you because I really hadn't thought of him. Or maybe I can do Aristotle as my model. I don't know, we'll see. Let's not stress about that. So what I'll say is, white men built their concept of science from the centuries of scientific endeavor made from the people that came before them, which was the civilization. Well, I would call the Nubian civilization, maybe the Egyptian civilization, but there was this interplay between the Mesopotamian region, where you find Middle Eastern and North African communities. And at the decline of their civilization came the rise of what I think we call the Greeks. And Aristotle was a philosopher in this new burgeoning Europe, right? One of the founders of the white man patriarchal frame of thinking. This guy and his peers felt that it was appropriate to put science in the field of philosophy rather than experiment and data. So they did a lot of thought experiments in order to understand and explain nature. In this particular case, I will use that as the starting point because that's the model that we use now. At least at the high school level, we're going to get as far as like a quantum mechanics level. So anyway, the philosophical prompt, or the thought question, the phenomenon that we're going to really try to tackle in about 12 minutes is the issue of halves. What they were trying to do was to determine the nature of matter itself. Another endeavor that scientists embark upon is, from a philosophical perspective, is understanding the nature of reality. What is real? You got two crazy people. They could see, not even that. You could have two witnesses to a crime, and they could see and experience two totally different things, right? They could have two totally different stories. So this happens not only in normal situations, but if a person is colorblind and they can't see red, well, then what color is red? You know, for that person, does red even exist? Or does it exist because we all told him that it's red and that he can't see it, right? And there's a grand conspiracy. So reality, or the nature of science, is to understand what is real, what is perception. Okay. Now, this is interesting. But to get back to the point, what we're really talking about is, what is the nature of matter? What are the things that exist? The nature of the things that are real. And so one of the questions was, is it continuous, or is matter discrete? AKA, if I take this piece of gold and I cut it in half, right? So let's say I have my magical, agical cutting machine that can take any piece of matter and cut it in half precisely. Then what would I have left? Over here I would have a smaller, approximately half piece of gold. Everybody's with me so far? If you're confused or you need me to slow down, let me know in the chat. You can smash that too, or give me some information in terms of what's going on with you so I know how to respond. All right. If matter is continuous, if matter is actually solid and not made of discrete pieces, then what that means is I could take this gold, I can cut it in half. Then I could take that half and cut it in half. And I'll take that half and cut it in half and cut it in half and cut it in half. And I could continue to cut it in half towards infinity, right? And I would never get a small enough piece, because that piece can always be cut into two other pieces, right? This is the infinite model, or the continuous model of matter. So when you look at, for example, a brick of gold, you say it's solid. You knock on it, you know, you can tell it's solid. Is it actually solid though? Or is it like made of discrete parts? Discrete, we can use the word discrete. So depending on the theory as I explain these, you let me know in the chat what you think. Is it continuous, or is matter discrete? Can I continue to cut in half until infinity, and I always get half, and then there's half, and I cut it in half, and I get half, and I cut it in half? Or was there a certain point where, you know, what do I say? There's 8 pieces, and I cut it in half. Now there's 4 pieces. I cut it in half. Now there's 2 pieces. I cut it in half. Now there's 1 piece, and there's only 1 piece, and that's the smallest piece. If I cut that piece, then I'm actually destroying it, right? It's gone now. And so that's the question. Is that gold bar made of a bunch of small pieces of gold, or is it actually 1 piece of gold that just goes continuously, and there's no space or pieces that make it up? Like a Lego building blocks, right? Okay, I think I've over-explained this, so let's continue. Here's half, and then that gives me this sliver. Now I'm going to turn it this way, and then here's half, and then I'm down to this, and then here's half, right? And then I just keep getting down. So the question is, would it stop at some point and say, okay, well, this is the smallest piece? Or can that smallest piece still be cut in half? Half and half. All right, so the chat, let's fill up the chat. Let's fill up the chat. Let's see what the people think. The philosophers at that time, so we can actually make Aristotle, I'll make him the first white man in our story here. Aristotle. And he came up with the basic sphere, which we now call the atom. Okay. All right, so we are now moving into the story of the white man's privilege, part 2, where I am now going to introduce more of the white men who have contributed to our current concept of the atom. We talked about Aristotle and his philosophical thought problem, which led us to the concept of the atom. And now we move forward hundreds of years. They relied on this. I mean, alchemy is littered with white logic. So it took them a while to move past the idea of science as philosophy. Science became like how do I say, property of religion for a while, until they finally started to use evidence. So we're pushed past the beginning of the transatlantic slave trade into the 1800s, kind of towards the end, the mid to the end of the 1800s, if you will. So anyhow, we've kind of moved forward, and there's a lot going on in history, which is why your research project is so important to me, because in addition to telling me about these men and telling me about the science experiment that they did, I'm kind of touching on it for you now. I also want you to tell me what else was going on at that time in history, so that we can add some context to these scientific discoveries, quote unquote. All right, so anyway, let's get back to the battery. So here I have a positive pole and a negative pole, as you're familiar. Think of this as maybe like a car battery, right, with a lot of electricity to generate. And then over here came this glass tube, which was called a cathode ray tube. I'm going to draw 3 of them because there was some interesting experiments under these 3 different conditions. And here's the 3rd one. And each of them have a piece of metal on each end. So I'm going to draw that as sort of like a T, if you will. Problem is I don't have my monitor up, so I can't even see if you see what I'm talking about here. Let's just make sure. Okay, we're looking pretty good. Slide it up a little bit. All right, so we put this inside of each, okay? Now, just to describe this clearly, this is a sealed glass. They basically used like a vacuum pump and removed all the air out, right? There's no super clean, there's nothing in it. They sealed the glass, or sometimes they had a continuous vacuum pumping the air out. And all that was inside of the glass, therefore, were these 2 metal nodes. Now, at this point, they know that electricity runs through wires. It's one of the properties of metal. So they know some of the properties that metal can conduct electricity, right? And other things. So they decided, let's run the electricity through, but leave this gap of space and see what happens. Now, in normal air conditions, either nothing significant would happen, or perhaps you would get a spark that looks a bit like lightning, right? A bit like an electric spark could happen, but nothing noteworthy. But once they removed all the gas, and the only thing in there were these 2 pieces of metal, when they ran that electricity through, then they found what is called a cathode ray. So here on the negative pole is where the electricities come in, and then this end is connected to the positive pole that receives those electrons, right? And this is how electricity runs, or this is how electricity makes things happen, right? But we can get into that a little bit later. What I do want to do is talk about what they noticed. And what these scientists noticed was something amazing. It was like a lightsaber in Star Trek or something. There was this beam of light, light rays, I don't know what to call it, this beam of light that was traveling from the negative piece of metal over to the positive piece of metal in conjunction with this electric circuit. So they knew that it was something. They could see it with their own eyes. It was really quite something. But they didn't quite know what it was. And it was J.J. Thompson who was experimenting with these cathode ray tubes, where in this case, the pink light was just flowing. And what he did, which was very interesting, was added a magnetic field. And so you'll find that there's this close relationship between electricity and magnetism. And so magnets also have a positive and negative pole, or a north and south pole, depending on how you want to put it. I'm going to put it as a positive pole. When he put the positive pole of the magnet on top, and then in this tube, he put the negative pole of the magnet on top. Now, when he started the battery and ran the electricity through, what he found was the beam of light went straight across. But when he put the positive pole, the magnetic pole, on top of that piece of glass, what he found was that this beam of light actually bent toward the positive pole. So this is an opportunity to hit up the chat and let me know what you think would happen if when he put the negative pole. Give me your prediction. Put it in the chat. Private chat would be ideal. And let me know what you think. What do you think would happen? What do you think happened when he put that negative pole there. I'll give you three options to give you a little bit more time to think it through. Option number one, the beam went straight, just like regular. The negative pole had no effect. Option number two, it did the same thing and also bent toward. Okay. Or option number three, you could say that it bent away and went down. So you have those three kind of logical choices to select. All right, I am going to go ahead and call it. So thank you all for contributing. Remember, if you're taking the class, this is part of your participation. So make sure that you stay on top. What in fact happened was it bent away, which was very interesting. Not only did it bend away, but based on the power of the magnet, he was able to mathematically predict how far it bent. So there was something real going on here and something that he could predict. Changing the metals was also very interesting, because when he changed the metals, he would sometimes get different colors of these light rays. Even though they would all behave the same in terms of how they bent, the metal determined the color and the magnetic field determined its arc, or how it bent. It was freaking phenomenal. But this led to a upgrade to the concept of the atom. What we now know is that these metals have a lot of electrons, and those electrons can move easily. This is what we call electricity, the movement of electrons. It is the electrons that are moving toward the positive pole, and what they are doing is getting excited. And that's where we get to this issue of emitting light up here that we're going to talk about in not too long from now. But let me continue on to the next experiment, or let me continue to the conclusions that were made. So then we have this entry of J. Thompson. Who knows? Maybe he's my former slave owner. In the cathode ray experiment, which then updated the model to what he was able to conclude. I wonder if you could tell me in the chat, what could he have concluded based on this experiment and based on what you know about how certain things attract and certain things repel? Do you think you can throw in an explanation? And if your explanation is reasonable, I'll throw some extra credit at you. So let me know your prediction. Meantime, I will show you plus, minus, minus, plus, minus, plus, plus, minus. Okay, something like that, as the new updated model. All right, so that's all the time I can offer for the extra credit. Thank you all who contributed. If you need some fresh ideas, you can see the chat. So, what he was able to conclude was that, number one, atoms were not very, very tiny, solid, spherical, like billiard balls if you've ever played pool, right? That's not what atoms look like. According to his experiment, atoms are actually made of smaller parts, which we call subatomic particles. And one of those particles must be negatively charged. Because of the way that it was behaving, around the positive pole, it was attracted, and around the negative pole, it was repelled or was pushed away. So that led him to conclude that there must be some negatively charged component. And if there is a negatively charged component, then there must also be some positively charged component, because ultimately these electrons seem to balance out their charges. Okay, so that is J. Thompson. If you did get him as your research subject, then you're going to tell me a little bit about J. Thompson, when he was born, where's he from, some little autobiography type stuff. Then in the second section is where you're going to tell me about this cathode ray experiment. Obviously ripe for an image. You're going to include 2 images still. And then your third is like the meanwhile, or the context section, where you tell me about other things that were happening at the time of his life. So you could go as early as when he was born, technically as late as when he died, maybe around the time that he did the experiment, but give us some historical context. All right, I'm going to move on to the next person, which is Mr. Rutherford and his gold foil experiment. So we'll go ahead and start that in just a minute.